Hi everybody. In this video we will learn about mole to mole conversions. We've been talking about moles since September, and this is the height of the concept that you learn in chemistry when it comes to moles. We are going to apply the concept of moles on balanced chemical equation, and that is called stoichiometry. So when we talk about molar relationship of a chemical reaction, it is called stoichiometry. So stoichiometry. It allows you to calculate the amount of different substances in a chemical reaction. So if I have A moles of substance A and B moles of substance B, which produces C moles of substance C and D moles of substance D, we want to find out like what is the molar ratio, molar relationship of these compounds. Like how many moles of this do you need to produce D moles of this compound, and how many moles of this is needed to produce D moles of this compound. So basically when we are talking about the molar ratio here, this is called stoichiometry. So molar ratio is the simplest one because you always have this information. So when we balance a chemical reaction, like you have 2 irons here, so that means you need 2 irons here. But before you do that, actually this is 3 and 2, so I'm going to multiply this with 2 and multiply this with 3. That makes it 6 and 6, but that makes iron 4, so that means you have 4 here. So that means once you decide this, once you decide this becomes the molar ratio. So 4 moles of iron is using 3 moles of oxygen to yield, I don't want you to call this a thing or arrow, it is yield. So 4 moles of iron need 3 moles of oxygen to yield 2 moles of iron trioxide. So this number that's coefficient is the number of moles. So molar ratio is the easiest question because that information is right there. You don't have to calculate anything. So the question is saying that how many moles of iron trioxide. So this is how you're going to do this. Pay attention. This is the easiest way to learn stoichiometry. You will not learn this process anywhere else. So you are saying how many moles of Fe2O3. So I want you to put X moles on Fe2O3. How many moles of Fe2O3? So you put X because you want to calculate the moles. If you have 2.59 moles of oxygen, so you have 2.59 moles of oxygen. This is the first step. The first step is write the info. Take these notes. Write the info from question above the equation. Alright. Your second step is copy the unit down. Now, if you be lazy and you don't write the unit, you cannot do the second step. So copy the unit down. So your unit here is mole, and your unit here is mole. So I'm going to copy the same unit down right here. Now how many moles is this? 3. And how many moles is this? 2. Cross multiply it and you have the answer. That's it. That's all you're doing. I'm going to repeat it because this is the easiest way you can learn stoichiometry. Right? So let's do it again. It says how many moles of Fe2O3. So you say X moles. Alright. You have 2.59 moles of oxygen. So 2.59 moles. So your second step is copy the unit down because sometimes there are different units that you're working with. It could be moles here and grams here. So but right now it's only doing moles. You have 2 moles right here and you have 3 moles right here. So cross multiply it and that is your answer right here. 3 significant digits because this is 3 significant digits. Alright, question number 2. How many moles? Let's write the equation first. So the only thing is that you have to write the equation every time you want to solve this question. So how many moles of iron? So you will say, X moles of iron are required to produce 34 moles of Fe2O3. So 34.0 moles. My next step is copy the unit down. Mole for mole and mole for mole. Now I have 2 moles right here and 4 moles right here. Cross multiply it and that is your answer. 3 significant digits because this is 3 significant digits. As I said, and I'm saying it over and over, that this is the easiest stoichiometry you can learn, where you have, instead of the other way around is that you start with your unit, you have 34.0 moles of Fe2O3, and then you see that 2 moles of Fe2O3 is using 4 moles of iron. Right? So moles of Fe2O3 get cancelled, you multiply, cross, and divide. So this is the dimensional analysis that we have been learning all this time. But when it comes to stoichiometry, it becomes harder because sometimes you have to keep doing this and it becomes a long question. So I taught you the easiest way it is possible. So then you have, this is taking too long. So we need to practice this. So let's practice that how many moles of hydrogen are needed to react with 2.5 moles. So how many moles of hydrogen? How many moles of hydrogen? Okay. So so X moles I put right here on hydrogen, and here I have 3 moles, and it says 2.5 moles of nitrogen. So 2.5 moles over 1 mole, cross multiply it, and you have your answer. So this is, as I'm telling you, this is the easiest way to learn stoichiometry. But you read the question that it says how many moles of hydrogen. Okay, so that means you're going to do X moles on hydrogen. So X moles. If you don't write the unit, you will not get any points. So if I only see X written there, you are in trouble. So it has to say X moles. Okay, and this is 3 here, so it's 3 moles, and you have 2.5 mole of nitrogen, and this is 1 mole. So I have no business with this. I will just leave it alone because I'm only solving these 2 things. I'm only comparing. So I can do this, or I can do this or this. It doesn't really matter which 2 compounds it is. So we will complete this practice in class, and that's all to talk about stoichiometry, mole to mole relationship. Thank you.